Hi everyone, this is coming to you from Education for All. We continue to solve problems under trigonometry and modeling. We got a couple of questions to look at today. This is the first one. The question reads, without using your calculator, find the exact value of a sine of 120 degrees plus 45 degrees, and second part, sine of 33 degrees cos 27 degrees plus the cosine of 33 degrees sine 27 degrees. But in all of these problems that we are solving, we are using the angle addition formulae or angle addition formulas. So when you see a problem like this, try to remember that you're going to use the angle addition formulae. Addition formulae. This is what we are using. And what are these angle addition formulae? You've come across them now several times. Sine of x plus y, cosine of x plus y, sine of x minus y, cosine of x minus y, the tangent of x plus y, and the tangent of x minus y. So these are the addition formulae they are talking about. So whenever you see problems like this, try to use these formulae to arrive at an answer. So, question 1 says, fine. Let's see at this one here. We are looking at A. It says sine of 120 degrees plus 45 degrees. You are not allowed to use calculator. Evaluate this. Find the exact value of this one. So, can we break this one further? No. There's no way we can break this one because 120 degrees plus 45 degrees, this gives us, if you add them together, 165. So if you subtract 90 here, 16 minus 8 is 8, so 60 minus 9 is 75. So still, that doesn't help. So we use the angle addition formula directly. So this gives us, when you have sine of x plus y, you will get sine of x, cosine of y, plus the cosine of x, sine of y. This is what you get. So the same thing here. When you have sine 120 plus sine 120 degrees plus 45 degrees, so this will give you, or rather it will give us the sine of 120, the cosine of 45 degrees, plus now the cosine of 120, then the sine of 45 degrees. So this is what you get. And you are told you shouldn't use a calculator. So what is sine 120? What is cos 45? And what is cos 120 without using a calculator? What is the sine of 45 degrees without using a calculator? So again, they expect you to use the trig functions. I think this video is going to be a little bit long. They expect you to use the trig functions. Cos 45, sine 45, that one, I assume you already know. But what is sine 120? Sine 120, if you draw your quadrants, you have C, I, S, T. Cosine, this is I means for all trig functions. This is sine, this is the tangent. And this is your first quadrant. This is your second quadrant. This is your third quadrant. And here is your fourth quadrant. Now you have sine 120. What that means, here, all trig functions are positive. In the first quadrant, that's what it means I. In the second quadrant, only the sine and cosecant are positive here. The rest are negative. In the third quadrant, only the tangents and cotangents are positive here. The rest are negative. Here, here it's only the sine, it's only the cosine and secant are positive here. The rest are negative. So now we are looking for sine 120 degrees. We know from here to here is 90 perpendicular. We need 160 degrees, 120 degrees. So we need 30 degrees more. So we need to go further 30 degrees. So plus 90 degrees. So now we have our 120 degrees from here to here. So what is left? This is a straight line. So this should be 180 degrees from here. So what is left here now is 60 degrees. 60 degrees. Our 120 degrees have taken us up to this point. What remains is 60 degrees. For the sine, we are looking for sine 120. But here, sine is positive. Sine is positive here. Only sine is positive here. So what this quadrant is telling us is that the sine of 120 degrees is equal to the sine of 60 degrees. That is what we are getting from the quadrant. So the sine of 120 degrees is equivalent to the sine of 60 degrees. So we have cosine of 120 here. So let's find what the cosine of 120 will be. So the cosine of 120 degrees, again, we are looking for 120 degrees. So 120 degrees stops here. So it will still remain 60 degrees to complete the straight line. But the cosine is not positive here. Only the sine is positive here. Here the cosine is negative. Cosine is positive only on the fourth quadrant and the first quadrant. The second and the third, cosine is negative. So therefore, here, although the cosine of 120 degrees equals to 60 degrees, but it will be negative. So the cos of 120 is minus cosine of 60 degrees. So this is all we need from these quadrants to find our appropriate sines. So what we have now here, we now have this is equal to sine 120, but we'll say sine 120 is sine 60. sine of 60 degrees, the cosine of 45 degrees, plus the cosine of 120, but cos 120 is minus cos 60. So we still have our cosine of 60 degrees and sine of 45 degrees. So minus plus minus, the minus takes precedence, yeah? So this now becomes minus here. That's what we need. Why do we reduce 120 to 60? You know the reason? Because from our trig identities, trig functions, we know what's sine 60, cos 45, sine 30, sine 9, sine 40, sine 90. All those ones we know, but we don't know what sine 120 is. How do we know them? Again, shall we do that? The video is getting too long. Okay. Now you know, when you have a triangle, you can say this is an isosceles triangle. All the three sides are equal. If all the three sides are equal, the angles in them are also equal. So this will be 60 degrees, 60 degrees, 60 degrees. So this gives us 180 degrees for the triangle. So I want to make the lengths to be equal. So I can give this one 100 units, 100 units, 100 units, it doesn't matter. I can give this side 1 unit, 1 unit, 1 unit, it doesn't matter. I can give 5 units, 5 units, 5 units, it doesn't matter. But for the sake of simplicity, I want to give it 2 units each. 2 units each. 2 units each. I can give whatever units. 2 centimeters, 20 centimeters each, as long as it's consistent. If I say 50 centimeters, this must be 50, this must be 50, because the angles are equal. So the lengths must be equal. So I decide now to give the length 2 units. These 2 units could be 2 meters or 2 centimeters or whatever. Right? Now, I want to find what I'm looking at here. I need, in this case, I need sine of 60. I need cosine of 60 degrees. There is no tangent, but suppose we needed tan of 60 degrees. And you need sine of 30 degrees. You need cosine of 30 degrees. You need tangents of 30 degrees. How do I get all these angles from this triangle here we have? So we can split this triangle into 2 equal triangles. We assume these 2 triangles now, they are equal. So what we have here now, instead of 60 degrees, this now will be 30 degrees because we have divided it. And here it was 2 units. Now this is going to be 1 unit here, 1 unit here. We need this length. This length now, we split the triangle into 2. What is this length? You know, from Pythagoras theorem, this is going to be root 3. You know how we find that one? I don't want to waste too much time. From Pythagoras, you know the hypotenuse, which is 2 squared, is equals to 1 squared plus whatever here, you call it x squared. So here 2 squared, you have 4 equals 1 plus x squared. Now you have 4 minus 1 equals x squared. So you have 3 equals x squared. Therefore, root of 3 equals x. This is how we got this one, root 3. Yeah, from Pythagoras theorem. So let's find first cosine of 30, sine of 60. Sine 60, so we are looking at this angle here. We can take this or we can take this one, whichever angle we take. So let's take this one. Sine is opposite upon hypotenuse. So sine 60 is equals to the opposite, which is root 3 all over 2. Hypotenuse is 2. What is cos 60? Cos 60 is the adjacent. Cos is adjacent upon hypotenuse. So cos is 1 divided by, cos is adjacent upon hypotenuse upon 2. So 1/2. Cosine is 1/2. Sine is opposite upon hypotenuse. Cosine is adjacent upon hypotenuse is 1/2. We don't need tan, so let me skip it. We don't waste time. We don't need tan. We don't need, yeah, correct. Just what we need, you know, these ones. So now we need sine 45 and cosine of 45 degrees. How do we find these ones? Again, let's modify our triangle. We have a triangle like this. And let's say this line is perpendicular to this, so they form 90 degrees here. Yeah, we assume, although it's not drawn to scale. So let's say this line is perpendicular to this. Yeah? So if this is 90 degrees and this is an isosceles triangle, meaning that the two sides are equal. The two sides must be equal here because this angle, this line and this line, they subtend an angle of 90 degrees. So these two lengths must be equal. So if I say this is 1 unit, this is 1 unit, I can say 2 units each, 5 units each. It doesn't change the procedure. So what will be this length? This, mind you, this is the hypotenuse now. Again, according to Pythagoras theorem, this length will now be the root of 2. 1 square plus 1 square root of 2. So if this is 90 degrees and these two lines are equal, it means here is 45 degrees. 45 degrees. This is 45 degrees. So when you add, you get the sum of 180 degrees for the triangle. So now, what is sine here? Sine 45, we're looking at this. Sine is opposite upon hypotenuse. So sine is opposite upon hypotenuse, which is 1 all over root 2. That is sine, opposite upon hypotenuse. What is the cosine? The cosine is adjacent, which is 1 again upon hypotenuse. So that is why you have sine 45 is equals to cos 45 degrees. They are the same. That's why you have the tangents of 45 degrees is 1, because tan is sine all over cosine. So when these two cancel, you get 1. So this is what we need now. Now we know sine 45 is 1/2, cos 45 is 1/2. Now let's solve the problem. Our problem is solved now. Yeah? So now we have, let me bring this one here. We have sine of 60 is equals to root 3 all over 2. Cos of 60 is equals to 1/2. Sine of 45, 1 all over root 2. Cos of 45, 1 all over root 2. For space, I need space. Right? So, what is sine 60 now in this case? We know sine 60 is root 3 all over 2. Cos 45 times 1 all over root 2. minus cos 60. Cos 60 is 1/2 sin 45. Sin 45 times sin 45 1 over root 2. So without using a calculator, we are finding the exact values. But you know, when you have, anytime you have a surd in the denominator, anytime you have a surd, you are given a problem and there is a surd, this is a surd, square root of 2 is in the denominator. You always rationalize the surd to give your final answer. Excuse me. Anytime you have a surd that appears in the denominator of the problem, you must rationalize it. So here, you're having root 2 divided by 2 root 2 minus 1 all over 2 root 2. Correct. So now, let us rationalize this surd, just what I mentioned. We rationalize this one here. So you rationalize this one here. This is going to give us now here we get root 2 times, rationalize this surd, is going to be root 2 all over, let me don't jump you, let me don't confuse you. This one here, you have your root 2 here, root 2 all over 2. If you rationalize this one, this is now going to be root 2 all over 2. What do you rationalize? What's rationalization of a surd? When you have it 1 all over root 2, what you do here, you multiply it again by root 2, and top again, you multiply by root 2. So the root 2 and root 2 will cancel. So you haven't done anything. You still have, because this divided by this is 1. But what you have done now, this now becomes a real number. Because root 2 times root 2, the square root of the square of a number is the number itself. So root 2 times root 2 becomes 2. Yeah? Root 2 times root 2 becomes 2. So that is why we have 2 here. So now you have 2 at the bottom, then you have root 2 at the top. Rationalizing. So that's what you get here. Here again, you have your minus 1/2 times root 2 all over 2. Yeah? So we can factorize the root 2's. So this will give us root 2, and you have 4 at the bottom. We are factorizing root 2's. So this will remain root 2 here minus 1 all over 4. So that is what you get. Here you just factorize. This is simple algebra now. Your root 2 will go out. Yeah, the denominator, you have 4. 2 times 2 is 4. 2 times 2 is 4. So that's why the 4 is here. You take root 2 out. So this will remain root 2. When you take root 2 out, only 1 will remain here. So this is your final answer. Thank you for watching. Bye-bye.